You've probably heard the term Apache Spark thrown around anytime someone talks about big data. But what is it really, and how does it actually work? Well, in this explainer, we're going to cut through the noise, break down the core ideas, and walk you through running your very first Spark job step by step.
All right, so here's our game plan. First, we'll tackle the big why. Why was Spark even invented? Then we'll get into the two things you absolutely have to know, the Spark session and data frames. After that, we'll reveal Spark's secret weapon, something called lazy execution. Then we'll put it all together and run a simple job. And finally, we'll look at where you can go from there. So what was the massive problem that needed a brand new tool like Spark? The source material really nails it. We got incredibly good, almost too good, at collecting data. Every click, every purchase, every little bit of information was getting stored. But trying to actually process that mountain of data with the tools we had, it was like trying to drink from a fire hose. We needed a totally new way to think about computation, and that is the world that Spark was built for.
Okay, so let's really dig into that. Because to get why Spark is so clever, you first have to appreciate the scale of the problem it was designed to solve.
Now, the key words on this slide are in-memory and clusters of machines. See, before Spark, other systems would do a calculation, write the result to a hard drive, read it back for the next step, write that result down, and it was just slow. Spark's huge breakthrough was its ability to keep the data in the computer's memory, which is super fast, across a whole network or cluster of machines. It was built from the ground up for teamwork.
So how do we actually tap into all that power? Well, to get started, you really only need to get your head around two main things. These are the absolute foundation of any Spark application.
First up, the Spark session. The easiest way to think about this is it's your key to the car. It's the very first thing you create, it's your connection to that whole cluster of computers, and it's the gateway to everything else you're going to do. You literally can't do anything in Spark without starting a Spark session. And this is what you'll be working with 99% of the time, the data frame. It looks and feels just like a spreadsheet or a table in a database. But here's its superpower. It's not actually living on just one computer. Its rows are spread out across that whole cluster. And that's the magic trick that lets Spark process these enormous data sets all at once, in parallel.
All right, so you have your data in a data frame. Now you want to start doing stuff to it. And this is where we get to Spark's most powerful and, honestly, most confusing idea for beginners. It's called lazy execution. In the world of Spark, there are only two kinds of operations. First, you have transformations. Think of these as writing down a recipe. You're telling Spark what you want to do. Hey, filter out these rows, or select just these 3 columns. You're building a plan, but you haven't actually touched any of the ingredients yet. The second kind is an action. An action is when you tell Spark, okay, I'm done planning. Time to cook. Run that recipe and give me the results. Which leads to the million-dollar question, right? If transformations are just a plan, a recipe, when does the cluster actually fire up and start crunching all those numbers? And the answer is, only when you call an action. Spark is, well, it's lazy. It's a procrastinator. It won't do a single thing until you absolutely force it to. But this is its greatest strength. Because it waits, it can look at your entire plan, your whole recipe from start to finish, and figure out the absolute most efficient way to execute it. It can shuffle steps around, combine them. It optimizes everything before running a single calculation. That's the secret to its speed. Okay, enough theory. That's a lot to take in. Let's make this real. Let's see what this actually looks like with a simple, concrete Spark job.
So we'll be using this little snippet of retail data. Pretty simple stuff. What was bought, how many, etc. Let's pretend we've already loaded this into a data frame, and our mission, should we choose to accept it, is to find out how many times someone bought a white metal lantern. So step 1, we define a transformation. We write a line of code using .where to filter our data. We're essentially saying, create a plan to find all the rows where the description is white metal lantern. But look at the status. Nothing is happening. No job is triggered. The cluster is just sitting there. All we've done is add a step to our recipe. And now, step 2. We call an action. In this case, .count. This is the trigger. The moment Spark sees .count, it says, aha, they need a final answer. It grabs the plan we just gave it, optimizes it, and fires up the entire cluster to execute that filter and count everything up. And just like that, it returns our result. Let's say it's 500.
And that's the core loop. You define what you want with transformations, and then you kick off the actual work with an action. Once you get that, you got Spark.
And once you truly understand that simple workflow, plan with transformations and then execute with actions, you have the key that unlocks this entire incredibly powerful Spark ecosystem.
Because here's the beautiful part. That same idea applies to everything else in Spark. Want to run SQL queries on petabytes of data? It uses transformations and actions. Want to process live streaming data as it comes in? Same idea. Building huge machine learning models or analyzing complex networks? You guessed it. It's one unified engine for almost any big data problem you can think of.
So there you have it. We've gone from the big why to the core workflow. You've seen how to build a plan and then tell Spark to execute it. The only question left is, now that you know how it thinks, what's the first question you're going to ask your data?